This is Let's Talk Higher Ed, a podcast for high school counselors and university admissions representatives worldwide who aim to help connect students to their dream schools. In each episode, we hold candid conversations with our community of students, their counselors, and universities to discuss everything from dealing with anxious parents to ensuring a seamless transition to university life. Let's get started.
I'm Tim Munlin, Senior Director of Education Partnerships at Cialfo. Cialfo helps counselors and students worldwide access higher education through a user-friendly interface that saves time. We also assist universities in finding the right fit undergraduate students from Cialfo's network of international high schools. On today's podcast, we chat with Dr. Rob Siddall, lecturer in robotics in the School of Mechanical Engineering at the University of Surrey. We deep dive into the engineering world of robotics and the career possibilities of studying engineering. Well, just introduce yourself to us. What do you do at the University of Surrey? What are you working on right now? And why are we talking about robots and studying engineering at the University of Surrey?
Sure. Yeah, so I'm an aerospace engineer by training. So I, did a lot of work with unmanned aircraft and drones, but in the past few years, I've been doing a lot of work with biology. So I've been working with lizards and squirrels and sort of small animals that do very interesting things, trying to use those to make better robots. So the more we can understand about how animals move, the more we can apply it to robotics. So here at Surrey, I have, a lab where we build all kinds of sort of like different contraptions, from fish to birds, all usually with some kind of focus on, say, monitoring the world, finding biodiversity, sort of that kind of thing. Right. And I also, as an academic, I teach the practical design course at Surrey. So all the second years basically spend the whole year with me. And we build a variety of different robots depending on what you're doing. So if you're biomedical, you probably build a robot hand. If you're mechanical, you're going to be building a disaster relief robot, aerospace, build airplanes. But yeah, so it's a practical design course where you get a whole year to build what you want, along with some cash to spend from the university.
Are you saying that I'm going to have a pet robot one of these days?
Yeah, it's not far off. They're getting smarter and smarter. They're not quite cuddly enough yet, maybe.
This is true. We're also been talking about, what an animal can do and how fast it can do. And you've been studying this for a while, and we'll link a really nice summary of the studying of animals and their relationship with robots. You were talking about how fast an animal can move across the terrain and the challenges that would put into making a robot that acts like that.
Yeah, so there are two things that animals do really well that robots don't. One is they're very efficient. So when you're an animal, it's really important to save energy. And the other thing is that they are very adaptable. So almost every animal, if you throw it in water, it will swim, even if it wasn't made to swim. Snakes swim, bats swim, sloths swim. I think the example I like to give is the Boston Dynamics robot dog, which is about as impressive as robots get. So that robot, about the same size and weight as a dog, but it consumes about 10 times the power as a real dog, and it can only walk a tenth as fast.
Well, let's go back. Let's say I'm in the audience today and I'm listening to this and I'm thinking, I'm hearing about AI, I'm hearing about robots. Where should I start as far as knowing that I might be interested in that? What would your 14 or 15 or 16-year-old self would be thinking right now that I might want to pursue something like this later on in life?
Engineering it's a creative endeavor, right? It's creation at its sort of most basic. You're trying to make something that doesn't exist yet. And in my experience, like, creativity comes from just sort of diverse experience. So, you got to do the math, you got to do the physics, but you've also got to exercise your imagination. And the way you do that is by filling up your head with, life experience, unusual stories. So I say, don't shy away from, art and literature. All of those will help you be an engineer.
Let's say that I'm interested in studying engineering at the University of Surrey. I come on campus. What is my year one looking like?
So year one, we have a common year across all the disciplines. which basically means you've got some options to choose down the line. So you don't have to come in and say, I want to do aerospace engineering, I want to do mechanical engineering. So everyone does the same first year, and that first year is it's the basics. So it's your math, it's your design work, it's your fundamental physics, and you'll get a little bit of experience. We'll try a variety of lab experiments, and you'll get a little bit of hands-on time in the workshop. And that is all to prepare you for, choosing your specialty and really focusing in on what it is you want to do, whether that be automotive engineering or biomedical engineering.
Okay. So general common core or just common classes first year, and then I'm going to start specializing into what University of Surrey offers. And the different disciplines that you offer at the University of Surrey are?
So we have automotive engineering, biomedical engineering, aerospace engineering, and mechanical engineering.
There's different ways to access engineering, maybe foundation pathways, things like that. What can you tell me about that?
So for those who maybe didn't do the right subjects in their sexual education, or maybe just missed out on, say, like sixth form in England, and want to do a degree, you can take a foundation year, which basically is a preparatory year where you basically do sort of engineering basics. We try and make it's a bit more maybe a bit more engineering focused, and you get some chances to do some hypothetical projects. I always work with a group of foundation year students who were designing a rescue drone for the Himalayas. So It's a quite challenging thing to sort of make a drone go to that kind of altitude. So you get to do a little bit of sort of fun engineering projects, and that leads you into just the regular degree course. And from there, you can choose bachelor's, master's, whatever discipline you like.
Great. That's a great way. That's something great to know about that if I didn't do the specific courses that were needed to gain entry, that I could do it there in that foundation year. So I decide I'm going to go into biomedical engineering. What are my options as far as getting some practical work, some maybe internships or work studies?
So we have loads of opportunities for that. First of all, at any point during your year, no matter what course you're on, you can take a year out and do an industrial placement. So the only requirement for that is you have to be mid-degree. So that's, say, between your first and second and third and fourth years. And we have a placement coordinator who can arrange placement for you, or you can just go out there and find one for yourself. Last year I was out in Bulgaria visiting a student who was designing cargo aircraft in Sofia. I've also seen students who've gone and spent a year working with ejection seats or with high-powered microwave heaters. So if you want to go out and get experience, you can do that. If you don't want to commit to the full year, there's summer work. There's also a research internship program. So right now I've got a student down the lab who's trying to do some artificial evolution with a 3D printer. And he's a university-funded internship student. So he gets 8 weeks of salary to try some research.
Also, if you've been watching Netflix, the popularity of F1 has skyrocketed. What's the advantage of your campus location and its relationship to F1?
So we have a huge dedicated space just for Formula Student. So we have about 30 students every year working on a car for the Formula Student contest.
Okay.
They have their own facilities where they got their own welding bay. They've got one student per year gets to be permanently employed just to be the sort of like a year-long Formula Student internship student. We've got a nice design center with loads of sort of computers, booths, hardware. So it's a nice facility for that. And of course, we're in the home counties in England, so I think almost every Formula One team have most of their sort of like operations based here.
Wow.
So
that proximity is advantageous for someone obviously taking your programs, being part of that, and then having access to all of those teams being nearby. Are robots going to replace humans? I'm hearing AI. I'm not, I'm scared. What's going to happen with the future of robotics and the human race?
I think robots have been replacing humans for 50 years, and people usually complain about it before it happens, and then when the robots come in, they free up space for people to do more enjoyable jobs. Typically, robots take the worst jobs first. I don't want to be flippant about because there are people. I grew up near a car factory, and the workforce shrank over my childhood, and I watched that happen. But there are still opportunities. the more complicated these engineering systems gets, the more they need people to sort of look after them. So typically they're taking the repetitive jobs, just the turning screws, spot welding. And now we're in a situation where robots are going to take some of the sort of like most unpleasant jobs in our society, cleaning sewers, that kind of thing,
Right.
and the menial tasks that weigh your life down. So, I spend a lot of my time doing laundry, and folding laundry is a huge, huge challenge for robots. Right, like folding a shirt seems easy for me, super hard for a robot, but we're getting there now, and it won't be long before robots fold your laundry, put your stuff away, and it frees you up to do things you like more.
Summer opportunities that you might have on campus, competitions, contests that students maybe internationally could take part in?
In the summer, current students go and they build aircraft and they go and fly them in international competition. So they're dropping parachute packages from an aircraft they built. I run a competition where we ask for people to submit designs for robots inspired by nature. So you find a problem the world faces and find an animal that can maybe solve it, and you submit it to me, and the prize is that me and a few other academics will build it into a real life robot. So last year we built a fish that collects microplastics in its gills. This year we're currently building the winning robot. I don't want to give away what it is.
Okay.
But we have submissions, like we have like trash collecting flamingos. We have vaccine delivering mosquitoes, which are a bit too scary to try and build. These kind of
It's
things.
fantastic. We'll link all of that information in the show notes so people can have access to that. But I like the idea of finding that problem and let's come up with a solution with it. Anything that helps us get rid of some of the waste that we have in the world. The flamingo robot sounds quite fascinating. I want to pivot back just real quick. If you've worked in industry, what is a day in a life of a mechanical engineer, or maybe engineering that you've done? What would be a typical day in a life?
I spend most of my time working for either startups or research departments where it's a little bit more reactive. But I think, so you come in and once a week you'll have a meeting where everyone will sort of discuss their problems and how you can solve them. You spend a lot of time working with design programs, analyzing data. And then eventually, once you've sort of like got design you're happy with, you'll send it to be manufactured or you make it yourself. And then you've got some time testing and debugging. So, I mean, typically, no matter what you design, the first time you design it doesn't work. As long as
Failure's your friend.
Yeah. I mean, the trick is to fail quickly and early so you learn the lessons.
Right.
So, basically you design something and you plan to sort of build 3 or 4 versions of it. So your goal is just to sort of work through those versions as quick as possible and learn as much each go.
Are there other extracurriculars that can be done by students once they get on campus to help pad out their resume or help them prepare for a profession in engineering?
Yeah, I mean, so we have a bunch of department-funded teams. They are run by students, supervised by academics. So I supervise, there's obviously a formula student. I supervise, we call it Team Periton, which is they build aerospace stuff. So we have one team who builds a satellite for a satellite design competition. We have one team that builds model rockets for a rocket competition. And we have another team that builds drones for a UAV competition. And Surrey have been doing quite well recently. We've won the IMEC UAS competition for the last 2 years running. This year we came second.
Any other activities that happen on campus that would be beneficial for students to know about or make them keenly interested in the University of Surrey?
You also get, unlike a lot of degree courses where you only do one project, you have an option to do 2 projects. So effectively 2 sort of thesis projects. So you do one in your 3rd year, and if you like it, you can do it again. And that's an individual project where you get budget from the department, you get supervised by an academic, and you can pursue anything that you find interesting as long as it's has a research justification. There's a student over there who's looking at ski jumping, trying to sort of optimize aerodynamic ski jumping. He's a keen skier. I have students who are they're trying to resurrect extinct dinosaurs. So we're looking through fossil records and we're trying to make a pteranodon that we can fly and test the aerodynamics of.
That's all we need is robot dinosaurs flying around If I'm listening to this podcast and I'm interested in all the things that you're talking about, I'm interested in learning more, some words of advice for that teenager and their families about exploring all the possibilities that come with an engineering degree, but then maybe even a focus on robotics. What are the words of advice you'd leave them?
So I think the way to succeed in your degree is to do something that you like. So the most important thing is to sort of figure out whether you really like this engineering stuff. I obviously love it, but if you want to figure that out, go and take a look at what's been done. So go visit your local space center, or local planetarium, your local racetrack, or buy something and tinker with it. These days you can buy for $30, you can buy a nice robot kit where you can build something cool, like a self-balancing robot, or try it and see if you enjoy it. Right. Because that's the trick to getting a good outcome in your degree, is to like what you do, so it doesn't feel like work.
Dr. Siddall, thank you so much for spending some time with us today.
No problem.
Thanks for checking out this episode of Let's Talk Higher Ed. This show is brought to you by Cialfo, a fast-growing global edtech company and student-first career exploration and college application network. If you enjoyed this episode, then follow Let's Talk Higher Ed wherever you get your favorite podcasts. Or join us online at cialfo.co/podcast for all of the latest episodes.